In the last video, we talked about two different rules for evaluating limits when you're just looking at the function. The first rule was that if plugging in the limit value in place of the variable, if that gives you an ordinary number like 7, then that's your answer. That is the limit of that expression. So limits are well behaved like that. The second is that if you have a limit as x approaches infinity and x is in your numerator, so your numerator is approaching infinity and your denominator is standing still, the limit is infinity no matter how big the denominator is. And so I want to talk about a separate case now. Let's talk about, once again, the limit as x approaches infinity. But this time we're going to turn the tables. This time I'm going to say the function is 1 over x. All right. So once again, let's pop over to a table just to give ourselves some intuitive idea. And this is going to form a rule so that in the future we don't need to look at a table. So when x is equal to 10, 1 over x is equal to 0.1. When x is 100, the output is 1 over 100, which is 0.01. For 1,000, it's going to be 1/1000th, which is 0.001. For a million, it's going to be 0.000001, 1/1,000,000th. All right. And so the question is, what is this limit approaching? Another way you could think about this question is we could think of it in kind of a physical context. All right, so let's say that we had one cake and we were splitting it up equally among all the people in a room. And the number of people in the room is growing without bound. Is more and more people are entering the room, and the number of people is not stopping at any point, even beyond the population of the earth. It's just, we're going to imagine having trillions and quadrillions of people in this party, and we've got to share the cake between all of them. So when just 10 people are here, we're assuming that each person gets 1/10 of the cake. That might be, a slice, maybe a generous slice, depending on how big the cake is. When there are 100 people, you've got just a tinier piece of the cake. 1,000 people, you get like a crumb. 1,000,000 people, I don't even think you'd recognize this much of a cake. You wouldn't even notice it when you put it in your mouth. And as the number of people get to be more and more and more, the amount of cake you get is less and less and less. So my two questions are, from an analytical kind of abstract perspective, what is the limit of this sequence? And in a more real world sense, how much of that cake do you get? Do we have a concept for the amount of cake that you get in that case? And the answer is, we don't need to call that 1 over infinity. We actually have a concept already in our minds from math about how much cake you get. You get this much cake, right? That's what 0 effectively is. It's a number that is, that's just when you get a crumb of cake, and then you get less than a crumb of cake, and then you get like a molecule of cake, and then you get an atom of cake, and then you don't even get that. You get like an electron of cake, and then you get a quark of cake, and then it keeps on getting less and less and less. The only number we can use to describe that amount of cake is going to be 0. All right, so you get no cake when there are an infinite number of people sharing it. All right, so here we can see the limit as x approaches infinity of 1 over x is equal to 0. And let me stretch this out a little bit, just like I did in the last video. What if we had the limit as x approaches infinity of 1,000,000 over x? All right, so now x is approaching infinity, but our numerator is really, really large. I mean, from our human perspective, this is a really, really large number. Does that change our limit, or is our limit still equal to 0? Well, once again, we could think about this in the real world perspective. If we're sharing 1,000,000 cakes and only 10 people show up, yeah, sure, that's a lot of cake. I get 100,000 cakes if I'm one of those 10 people. And if 1,000,000 people show up, then I get an entire cake to myself at that point. But infinity is so much bigger than 1,000,000. It's just a concept that we can't even fathom. So more and more people are showing up to this party, and as that happens, my whole cake becomes a slice of cake, which becomes a crumb, which becomes less and less and less of it. And once again, the limit of this is zero, no matter how big that numerator is. All right, so that's going to be our rule 3. All right, so rule 1 is that if substituting a limit in gives you a number that makes sense, then that's your limit. The second thing is that if you're doing a limit in infinity and the numerator is approaching infinity and the denominator isn't, that limit is infinity. Our third rule says the opposite, that if the numerator is standing still and the denominator is approaching infinity, then the limit has to be 0. All right. Now, in the next video, we're going to talk about some more complicated cases where both the numerator and the denominator are changing. And we're going to see if we can use some algebra tricks to figure out what the limit are in those cases.